Welcome back to Aisha's Academy, and today's video are on box plots, so all about understanding box plots. So let's get right into it. So box plots is another type of statistical data where basically it's in the name. In the old school way, they used to call it box and whisker plots, so you may see it like that. And basically they're used when splitting up data into quartiles. So here is our box plot. And this is how it's drawn, and there's 5 key labels I'm going to point out in regards to knowing these. So the first thing is that at the lower end, that long stick, we call it the lowest value, and the highest end, we call it the highest value. Then the lesser part of your box is called the lower quartile, and the highest part of your box is called the upper quartile. And then the middle part is called the median. And last but not least, the distance between your lower quartile and your upper quartile is called the interquartile range. And to work this out it's the upper quartile minus the lower quartile. So now we're just going to crack on into some example questions. So example 1. It says write down the median. So we know that the median is the line in the middle of the box. It's not always directly in the middle, but it's the line within the box. So in this scenario, it would be 37, and that's literally it. Then it says work out the interquartile range. So we know our interquartile range is our upper quartile, which is the top end of the box, minus the lower quartile, which is the bottom end of the box. So then we're just literally going to subtract those two values away from each other. So that's going to end up being 71 minus 35, and that's going to leave us with an answer of 36. And then it says compare the two distributions. It's given us another set of data. So in regards to these compare questions, there's a few things that you just need to compare in order to gain your marks. So the first thing to compare is you need to compare the two medians of the two different datas. And the second thing is you need to compare either the interquartile ranges of the two data, or you can compare the ranges, because our range is our highest value, take away our lowest value. So either one between those two, but always median and either one of the ranges. So in this scenario, I'm comparing the two medians, and I'm saying that the median of the Summer Olympics is greater than the median of the Winter Olympics, because for the Summer Olympics it was 121 and Winter was 37. Then now I'm working out the interquartile range for the Summer Olympics, which was 116. And so if I'm comparing the interquartile ranges, I can say that the interquartile range of countries in the Summer Olympic is greater than the Winter Olympics, because it was 116 compared to 36. Example 2. So again, another compare question. So first thing first, we're going to compare our two medians. So for the 18-year-olds, the median value, and for the 16-year-old, median value is the middle line in between the boxes. And so for the 16-year-olds, the median was 180, and for the 18-year-olds, the median was 240. And so I can say that the median for the 18-year-olds is larger compared to the 16-year-olds. And then now I'm going to compare the ranges. So last time I did interquartile range, but I'm just going to show you that you can do it for ranges as well. So just to refresh your memory, range is the highest value, take away the lowest value, which, remember, they're the highest tips, the sticks at the end of the box plots. So that would be our highest values for both 16 and 18-year-olds, and then the other end would be the lowest values for both 18-year-olds and for 16-year-olds. So then if we work out the range for the 18-year-olds, it would be 380 minus 130, which would be 250. And then for the 16-year-olds, it would be 310 minus 80, which would be 230. And so we can say that the range for both 16 and 18-year-olds are similar, however, the 18-year-olds is larger. So example 3. So now it wants us to draw a box plot. So we know that the stick at the lower end is our lowest value, so we can plot that down because it's given us the least height. And then we have to draw that line connecting the lowest value and the lower quartile. We know our lower quartile has given us that, and we know our median. So to work out the upper quartile, the higher end of the box, we're going to add our lower quartile and interquartile range, which is 168. So we can now connect the lower quartile and the upper quartile together. And then now to work out the highest value, because we haven't been given it in the data, highest value would be the least height plus the range. So that's going to be 174. So then we can connect that. And that's literally our box plot. Then it's now giving us a compare question. So we're comparing the distribution of the height of the year 11s and the year 7s. So we know the median for the year 7s is 157.5, and the median and the range for the year 7s is 24.5. So we can say that the median for the year 11 girls is greater than the year 7s because it was 165 compared to 157.5, and the range for the year 7s is greater than the year 11s because it was 24.5 compared to 20. And that's basically it on box plots. So I hope that was really useful. Thanks for watching.